In earlier lecture of mechanisms of heat transfer, we talked about conduction. Here, we'll talk about the second method, which is convection. So convection is another mechanism where heat can be transferred. So what is convection? Convection is transfer of heat by mass motion of fluid. So convection is transfer of heat by mass bulk motion of fluid. All right, and this motion could be natural. So this motion could be natural, or can be forced, right? Um, so if the fluid is circulated by a blower or a pump, the process is called forced convection. Right? If the flow is caused by differences in density due to thermal expansion, such as hot air rising, the process is called natural convection or free convection. All right. The convective heat transfer is a very complex process, and there is no simple equation to describe it. We can here talk a few experimental facts that the heat current due to convection is directly proportional to the surface area. So we can say that P convection is directly proportional to the surface area, right? And these are experimental fact, right? Surface area. This is the reason, because of this reason, P convection is proportional surface. This is the reason for the large surface areas of radiator and cooling fins. Second thing is that the viscosity of fluids slows down natural convection near a stationary surface, giving a surface film. Forced convection decreases the thickness of this film, increasing the rate of heat transfer. And this is the reason for the wind chill factor. You get cold faster in a cold wind than in a still air with the same temperature. So, if I have to put it down here, second one is the P convection. You can think is inversely proportional to viscosity. Right. Third one is the P convection is proportional to temperature difference. So maybe let me write it down. Temperature difference between the surface and the main body of the fluid, okay, and to the power 5/4. So again, this is experimental data. Okay, all right, great. And convection, so maybe it's just like V, convection, not conductivity. So third mechanism is, so we can say third mechanism is of heat transfer is radiation. So let's underline. So this is my third mechanism. This convection was my second. So radiation is transfer of heat by electromagnetic waves. So it's a transfer of heat by electromagnetic waves, such as light, visible light, infrared, or ultraviolet radiation. Okay, so such as light waves, right? Light waves. All right. Okay. All of us have felt the warmth of the sun's radiation and the intense heat from a charcoal grill or a glowing coals in a fireplace. And most of the heat from these very hot bodies reaches us not by conduction or convection in the intervening air, but by radiation. And this heat transfer would occur even if there were nothing but vacuum um, you between us and the source of heat, right? So um, unlike convection and conduction, where you need a medium to transfer heat, radiation does not need any medium. And the the P, let's write it, P radiation uh, is can be written as A epsilon sigma t to the power 4. Um, and let's go one by one. A is surface area. Epsilon is called emissivity. And its values changes lies between 0 and 1. And sigma is called Stefan Boltzmann constant. It's a constant which is equal to 5.67 times 10 to the minus 8 watt per meter square per Kelvin to the power 4. And T is the temperature in Kelvin. All right, okay. So let's write down the equation again. P radiation is equal to, we saw A emissivity sigma t to the power 4. Right, so a couple of things here. The T must be in kelvins, and emissivity is greater than equal to 0 or less than equal to 1. So emissivity lies between 0 and 1. And with E is equal to 1 is called perfect black body. Perfect black body, which is kind of an ideal case, but a perfect black body is an ideal emitter, but also an ideal emitter is ideal absorber. So we can talk here also what happens if the rate, we can talk P absorption is equal to rate at which an objects absorb energy. An object absorbs energy from its surrounding, from its surrounding or environment. So that is given by P absorption is equal to A E sigma T, and this is the T of the environment, to the power 4. So if you have an object, let's say this is my object and this is on temperature T Kelvin, and I have here, this is my T surrounding or T environment, right, and that's also in Kelvin. Then net P, net rate of transfer of heat energy, is equal to A E sigma T to the power T environment, let's say T environment, to the power 4 minus T to the power 4, and that is here. Okay, so let's put in a box. And what it means is that P net is going to be positive if the net energy is being absorbed by radiation, and negative it is being lost by radiation.